This is a webinar series on geothermal heating and cooling, brought to you by Mission Geo and GeoExchange. And very pleased and very excited to have a wonderfully smart, talented, and informed group of panelists to talk to us about geothermal heating and cooling and geothermal heat pump installation, with a real focus on what is a growing technology in terms of heating and cooling for the economic and energy security benefits it provides, and for all of the other good things it can do in terms of cost savings and in terms of grid resilience, and want to provide some real world, practical experiences. We've got four very informed panelists, so I want to get right into it and not waste too much time with introduction. I'll just say I'm Scott Stone of Glencoe Strategies. I'm an attorney and policy advisor and work a lot on heating and cooling issues, and will be moderating today's session. So without further ado, would like to have Larry Leliefeld step up.
Hey, Scott, thanks for having me today. I'm Larry Leliefeld with Geothermal Eco Options. We are a ground loop installer based in the Midwest. We serve Illinois, Wisconsin, Minnesota, along with Iowa, and we do all types of ground heat exchangers, whether it's vertical, directional, pond loop, etc.
Great. So Larry, geothermal implies we've got to go underground to get at the heat, and that's what you do. I'm wondering if you could just tell us, what is a typical day at the office for you like in terms of drilling and putting in loops and installing the equipment.
Our typical project starts with communications from the heating and ventilating contractor. We do the outside work, which would then connect to the indoor equipment. So we work with them to determine the size of the project, and they will do a heat load calculation, which then gives us the information necessary to put in the correct footage for a closed loop. And we take that information, make a home visit, study the ground conditions to determine the most efficient and economical method for the homeowner to get that thermal energy transferred from the ground into the equipment. And depending on the conditions, we can look at vertical, directional, slinky loop style, etc.
And if you could, we have a mixed audience. I think we have some people who know a whole awful lot about this and others who are newer to this space. How would you contrast, geothermal heating and cooling with a traditional HVAC system?
We spend a good amount of time educating customers on the differences between a conventional system and a geothermal heat pump system. For the size of space in the home, the geothermal unit is going to take up about the same amount of space, yet it does both heating and cooling. So we work with them to help them understand. Right now you have a typical AC unit sitting outside, and that wouldn't be necessary with a geothermal heat pump. You would be able to have both heating and cooling performed with one unit. And we explain how we utilize a fluid that will flow outside into the geothermal loop system to help extract energy, either pulling energy for warmth in the winter, or help take the heat from the house and circulate it out into the ground to get rid of it in the summer.
So let me give you two scenarios. One is a big rural property where there's a ton of land. The other is an urban property where there's hardly any space at all. So you get the call and you're headed over there. For both, though, how do you overcome the skepticism of 40 or 50 degree water able to heat a home? How do you break that down and explain how this works?
That is a very valid point. We do hear that frequently. The type of loop and how it functions is an educational process. We do explain that the equipment itself has a refrigerant process, and that the thermal energy and the control of that energy and the consistency of that temperature is what allows the geothermal unit to operate, and that it's simply transferring or flowing a fluid. There is no creation of energy. It already exists in the ground. And for us, the most time is spent on helping them understand it's not necessarily just the size of the property they own, but what exists beneath the ground. We have an opportunity for either vertical or directional. And when we look at the property, we will determine if you have the space and there's plenty of soil or capacity for geology to do directionals. It's been a more popular method. It can be placed underneath existing structures. It can go underneath gardens, you name it, that would typically be thought of as having to be dug up. So if there's possible conditions that allow us to do directional boring, it does minimize the amount of excavation needed. On the other side, if you're in town, if there's a smaller space, going vertical is absolutely a possibility no matter where you're at. It's just drilling through harder surfaces, rock, granite, limestone, that type of a geologic condition takes a little bit bigger equipment and a little bit more of a process to get the drilling done and get the loop in the ground.
And so we all know what the conventional, HVAC van looks like, that pulls up outside the house or in front of one of your neighbors. But when you show up, you bring a little bit more than a van. Two questions for you. Describe a little bit, just what the scale and type of drilling rig we're talking about here. And then, what types of jobs, what types of careers that these represent. This is specialized knowledge, this is highly skilled work, and the opportunities it can afford in terms of, the way in which this industry creates jobs and the types of jobs, that are created by it.
Well, I like that lead in. The equipment that we utilize does vary based on the grade ground conditions. So a directional boring machine, many people have seen them putting in water lines or drilling underneath a roadway to put in fiber optics. That type of technology, a track mounted machine, is one that we use for directional boring. So when someone calls us and we're there to do our install, there's a drilling component. So whether that's the directional drill or it's a vertical rig to do the rock drilling, similar to what you'd see as a water well, it's the same type of equipment. We'll have a mobilization of the drill and then a trailer with our support materials along with it. We will utilize a lot of water at the site when we're doing our installation. So when we get set up, we do take a little bit of space, but when we're set up and running, it is a typical drill rig, a support truck, and a trailer that they would expect to see on the site.
And in terms of the jobs, I mean, I know from when we talked, beforehand, you have some experience with career counseling. And, what kind of a job, what kind of a career is this to be, installing, geothermal heating and cooling equipment, commercial, residential, all over the country? Would you recommend it to young people looking for something to do?
Absolutely. A career in this industry has both educational and environmental opportunities, you might say. And I go environmental from the standpoint that you're outside. A job that a typical job would have outdoor long hours. We'd equate it to like a farming style occupation where you're going to, work when the sun shines, you might say. And if you enjoy being outside and enjoy the long hours, it fits perfectly. an entry-level job could start as a driller's assistant. It could start as skilled labor, but we look to grow from within. And in order to do the work we do, we transport all of our equipment from job to job. So you're looking for people that can help transport. So there's ability to be a skilled laborer, a truck driver. Once the equipment's on site, they're operating equipment. So you have equipment operation involved. And as those skill sets are attained, then there's opportunities to help look at work, to do project management. The opportunities are expected to grow, and we like to enhance those. In order to become a driller, it takes a dedication, staying on the job, and also an experience of typically a couple years before you're even able to take the testing as needed for state certification to become certified drillers. So we look to grow from within and look to provide those opportunities and assist in those trainings, almost always paid for by the employer. So it's a great career path without a lot of upfront training necessary. So there's not a lot of college debt incurred in order to explore opportunities in this up and coming industry.
And I imagine there's transferability or at least comparability to the oil and gas industry, where there's a lot of drilling there and heavy equipment type work. Is that a fair comparison?
The skills throughout a day, I have a training program that we follow. It's a registered training program, and we help to explain that throughout a given day, you hold multiple job descriptions. You may start off as a laborer helping to get the equipment loaded. You might take on the commercial driving capabilities to inspect the load and haul it. You then find yourself operating the equipment, which is another aspect. And then you record depth, you record samples of the material that you're drilling, and that puts you in an inspection standpoint of project management. So throughout the day, experienced driller is a combination of all of those. And that's what makes the job challenging yet rewarding, because even with dirty hands, you're calculating very important data to deliver the success of the job.
That's great. Well, I'll tell you, in closing, my son, who's now half a foot taller than me, when he was 3 or 4, I mean, we didn't go to playgrounds, we went to construction sites. So I imagine you've probably had more than a few toddlers who, when you guys are at work, must come by and have to check out what's going on. And I think we missed a trick not installing a geothermal rig at our house when he was younger, because he'd probably be working for you at this point.
It is very interesting. We look at it as an attractive challenge. When you're on a job site, you appreciate questions, you appreciate the interest. It's a site that respect for safety is necessary. So you want to make sure people have an opportunity to ask questions and yet keep them safe in seeing what equipment's necessary to do it, to install the loops. And the biggest part for us is to engage all levels of opportunity, whether it's a middle school asking you to do a presentation, or you allow a job shadow to help educate for our industry what positions are available when it's not necessarily obvious. When you say installation of a heat pump or a ground heat exchanger, it's not as simple as well driller. So it's great to involve as many people as we can to bring more exposure to our industry.
Terrific. Well, thank you, Larry. And if we can circle back in group discussion, if time permits, we will. I'd love to move on to Peter Ernzen now. And Peter, welcome. Would you mind introducing yourself?
Yeah, hello. Thanks for having me. My name is Peter Ernzen. I'm a senior mechanical engineer with IMEG. IMEG, we are a nationwide consulting engineering firm. We specialize in the commercial building market.
And so, Peter, after guys like Larry have come and done the work, tell us what it looks like in terms of the customer experience in terms of energy savings and other benefits? What is that profile like once everything's been installed and is operating?
Yeah, typically with the geothermal heating and cooling systems, we usually see, there's usually an upfront cost, but you're making it up for it in the back end on an annual basis. So I know one project in particular that I worked with, and Larry and his company did the install for in northern Iowa. We looked at that project and its energy savings, and we were able to get an annual energy savings of about $50,000 per year compared to a traditional HVAC system. So that's just in energy savings. And then in maintenance savings, we're also able to get another about $5,000 a year in annual maintenance savings there.
Yeah, because in terms of the useful life of the equipment, I mean, outdoors, it's significant. What is it, up to 100 years, if I remember correctly?
Yeah, 100 or 50 years or somewhere in that. I think some warranties, depending on the piping systems, are 50 to 100 years. So that piece is a long lifespan piece of the puzzle.
And then, once it's in, we've talked about, offline, how some customers feel, more independent, more resilient, from an energy standpoint and whatnot. Could you elaborate on that, and talk about the types of designs or types of projects that, once installed, a lot of work to get it done, but then once done, really does create a strong feeling of independence from an energy and from a heating and cooling standpoint?
Yeah, absolutely. I mean, you're using a little bit of electricity from the grid, but as Larry mentioned, you're using the heat energy that's already in the ground below you. So you're pulling that heat energy up from the ground and using it in the winter when you need heating, and then you're pumping it back in when you're needing cooling. So a lot of the savings that we're seeing, the annual energy savings, is a reduction in electric usage as well. So that helps free up things, that you can do operationally by having an annual savings, reducing that electric bill every month or every year allows you to do a lot of other things as well. Another nice thing there is being able to have that opens up doors for, future possibilities of, putting some on-site renewables or things like that to completely separate from the grid if that was something that wanted to be done in the future.
So if you're and I think I'm gonna make sure I get the term right. So if you're a prepper, this is a good technology to invest in. And also just in terms of, swings in commodities and availability of components, this really does set you up for a good long time.
Yeah, it really steadies your, annual expenditure because it's a very constant system.
How do if you were counseling, let's say a couple of different scenarios, one would be just a typical single family home. Second would be a business, a small or mid-sized, building. Third would be a much larger, group of buildings, almost like a college campus. How would you, or what kind of advice, do you think decision makers for heating and cooling in those scenarios would need that would help, fully reveal and underscore the benefits of geothermal heating and cooling?
Yeah, and I would say it's very similar for all three scenarios. And the main point is look beyond just the first initial cost. A lot of times, geothermal heating and cooling systems, like I mentioned, they're going to cost a little bit more because you got to put that well field in up front compared to a traditional HVAC system. But if you're able to look beyond that first cost and really look at what are you going to save from an energy standpoint, what are you going to save from maintenance? How is maintenance going to be helped and improved as well? Those are things to really look at and consider. A lot of times what we do is we look at a total life cycle cost analysis for a building. So we would do that for all three of the scenarios. And many times when you look at that, you're able to see that over the course of, even just 5 to 10 years, you can get a payback on a geothermal system. And if you're going to do a life cycle cost over the course of, maybe 25 years is pretty common for systems and equipment. Almost every time we're able to see a good payback, whether that be in residential. We've seen that as well. The project that I mentioned with Larry was kind of a smaller size commercial project, and they were able to get a payback of about 5 years, simple payback there. So that was a really good payback for them. We've done a college campus as well in central Iowa, where they have 4 buildings. It was a new college campus. And we looked at many different systems, and out of all of those, in a 25-year life cycle cost analysis, a geothermal HVAC system came out with the lowest payback. It was pretty substantial. So they were able to get about a 10% return on investment, and they have a simple payback of about 10 years for that campus with that system. So
There's a bunch of college campuses that have deployed geothermal heating and cooling. Would you know of others that are out there that could be good reference points for those, following on at home?
yeah, I do know that there are several. A lot of them would be either newer campuses or small to mid-sized campuses. I do know just locally around here we have in the Des Moines area, it's Des Moines University was a new campus built about a year ago. And it's completely a geothermal heating and cooling system. I think there's 700 vertical wells on that system there. To serve all 4 buildings and to provide future expansion. They bought a site with 88 acres, I think, and they're only taking up a small portion, and they're ready to grow in the future. So that was also a part of it, is having a central geothermal system was to allow them for future flexibility for expanding and growing. It's a lot easier on their end as opposed to a chilled water plant or a steam plant or something along those lines.
Yeah. So that's interesting to me that there's not a lot of difference whether it's a single family home or a college campus. The cost benefits, the maintenance benefits, nothing really changes. You frankly just get the benefit of scale, but there aren't trade-offs that are had big and small, a rural setting, a more urban setting. So correct me if I'm wrong, but this is a highly versatile heating and cooling technology.
Yeah, absolutely, very versatile. And like I said, it's not very different. The only difference is the space and the space available for the well field, and then the size of the well field. But obviously that also scales with your building. We need a much smaller well field for a residential house compared to a college campus. And generally, if you have a college campus, you got a lot more space available there too.
Yeah, for sure. Sure. Well, one thing I'd like to close on as we segue to John Thomas and a manufacturer perspective is, the geography. You've mentioned Iowa. I know in the past, I'm a Big Ten school guy, and it seems like any state with a Big Ten school seems to have a pretty good geothermal presence, but that's not the only geographic area that this really can work just about anywhere. Is that correct?
Yeah. There's, I think Larry mentioned, whether you're doing directional boring or vertical or slinky type, there's a lot of different options. So if you're in a spot where the geology doesn't have a lot of rock, it's, clay, sand, Midwest type, the directional boring works really well there. If you do have a lot of rock or bedrock or limestone or whatnot, like the project that I mentioned that I worked with Larry on, that was one thing that we ran into. Was we originally designed it for a directional bore, but then when we got on site, there was a lot of rock there, and so what we did is we shifted gears and went to a vertical bore field, and so we were able to do that. We've also had several other buildings, usually on the commercial side, where they may have a pond or a lake built as well, part of the stormwater system. And we see that also on college campuses. And they're able to do kind of like a, the slinky type system in the pond or the lake there. Or you could do that under a residential facility as well. So very flexible. And I know Larry mentioned, with directional boring going under buildings and stuff, we've had direct experience of that with a local high school where they wanted to do an addition, and we had to do a directional bore underneath the existing building, and it worked really well.
Great, terrific. Well, thank you, Peter. This was great. And we'll see how much we can circle back if time permits, but this was great. And let's pivot now to the manufacturer's perspective. And John, would you mind introducing yourself?
Yeah, absolutely. Thanks, Scott, and thanks to the rest of the panel for joining us today. John Thomas, I lead the WaterFurnace business. I've been here for the last 8 years with the team, and we're located in Fort Wayne, Indiana. And I guess I'll just put a plug in here that we walk the talk of geothermal heating and cooling. So we've got nearly 250,000 square feet of operating facility here, and we heat and cool and make all the hot water for the entire facility from the bottom of our 3.5 acre pond.
Terrific. And so at WaterFurnace International, you're making the equipment that guys like Larry and Peter are installing. Tell us about what you make and what the market looks like right now in terms of where there's demand and how you're working to meet that demand with your business.
Yep. Okay. So I'll try to break it down in two main categories. The residential side of the business that's been referenced in some of the dialogue from Larry earlier. These are single family homes that can be very moderate in size up to very large homes, as well as multi-family dwellings, whether that be apartments or condominiums. So that whole spectrum of residential structures across the U.S., we're making the geothermal heat pump that connects to the loop that Larry installed, and we're using that circulating fluid from the ground and pulling heat out of it to keep your home comfy cozy in the wintertime, and then pushing the heat back into the ground in the summertime to keep it cool and at a humidity level that is acceptable. On the commercial side, it's kind of along the lines of some of the diversity that Peter was talking about. So commercial can be everything from a doctor's office or a dentist's office, a small retail restaurant, all the way progressing on up into every size of building in between that. And one of the most recent large projects that is just finishing up is we just retrofitted and supported an expansion in Louisville, Kentucky for the Muhammad Ali Louisville Airport renovation and expansion. And that obviously is some very large equipment that coupled together would be a couple times bigger than a large minivan. And those are in the mechanical room of that facility, multiple tons of cooling capacity that would serve the entire airport.
And so we've hit on a couple of, the benefits, obviously, in terms of, operational cost savings, performance, and reliability. I know we don't want to get too far down into the weeds, but I think we could make an exception from a manufacturer's perspective. In terms of the types of equipment you're making, and in terms of those values of the overall, geothermal heating and cooling approach, what are some recent innovations, or what are some focal points for you in terms of equipment design and manufacture that you're focusing on that help deliver, and ensure those cost savings and underwrite that reliability? Yep.
And I think that's a great lead in. Reliability of heating and cooling equipment it's kind of the asset that building owners and homeowners have, that we don't really talk about it all that much, but we know when it doesn't work. And we get uncomfortable fairly quickly, whether it's in the winter or in the summer. And so the reliability associated with equipment is important. And the integration of advanced controls in terms of managing how the machine operates and responds to different outdoor temperature conditions and responds to different conditions in your home. To look at the residential side, the advancement of the integration of controls to improve the operation has impacted comfort, and it also impacts reliability because we make sure we kind of keep the machine between the lines, so to speak, so we're not running off the edge of the road. And that helps from a reliability standpoint, which is important because when you're investing in this system that may cost 1.5 to 2 times what a traditional system does, the reliability of the equipment, it typically lasts twice as long because it's under lower stress and it's operating inside the facility. If you let me nerd out on one more point in that area, I would go ahead and highlight the advancement of variable speed operation. So in the old days, and some HVAC equipment today still operates like a light switch on your lamp in your living room. It's either on or it's off. And that certainly provides a function to keep your home properly conditioned for heating or cooling, but it's not the most efficient way to manage that. And so variable speed systems, for those homeowners out there or building owners, if you have people saying it's too warm in this room and it's too cold in this room at the same time, that's temperature stratification. And variable speed systems that operate continuously go a long way, and sometimes with zoning, to be able to make sure that everybody in the home, every bedroom, and all areas of a commercial building facility can be equally comfortable.
That's great. I mean, I know in our house, whether it's too warm or too cold, just depends on whether there's more than one person in the room. But still
Yeah.
very, very useful. And I think also importantly is, this is all equipment, this whole industry, this is as made in the USA as it can get, right?
I think so. Yep, absolutely. So all the major manufacturers that comprise over 95% of the market, I will estimate, are operating domestically right here in the US with still a significant amount of domestic content of local manufacturing and fabrication on the components that are used to build this equipment.
And then to zoom out a little bit, to touch on briefly the benefits that this kind of technology has for the power grid. I'm wondering if you could speak to a little bit about, what do electric utilities value in terms of having geothermal heating and cooling operational within their areas of operation?
Yep. So I'll make what might be a bad analogy, but I'll give it a try. So an electric utility, when they're generating power to provide to our homes or our industrial facilities or our commercial buildings and offices, just like I'm sitting in now, their best operating mode is no different than you operating your car on flat land at 55 or 60 or 70 miles an hour cruise control. They want to operate very consistently. The challenge is the demand of power has terrain like some exciting roadways, and that terrain changes as a function of the time of day and the temperature outside. So in the morning, when we're getting up in the morning and getting ready to go to work or putting kids on the school bus to go to school, there is a spike in the morning, and you can imagine we're coming off a cold winter night in Minnesota or Fort Wayne or Dallas, Texas. Doesn't really matter. If it's been a cold winter night, the heating system is kicking in strong, trying to recover to the thermostat setting that you've prescribed it to. Same thing happens in the evening when everybody comes home, electrical demand goes up. And so managing that terrain in those peaks and valleys is extremely challenging for power generation facilities across an investor-owned municipal or rural co-op utility, as well as the grid operators that are trying to tie all these different networks together and balance the load. So what geothermal heating and cooling does, because of the heat exchanger that Larry installs and the equipment that Peter designs and puts into their customers' buildings, it operates in a range of 2 to sometimes 3x the efficiency when it's cold outside and when it's very warm outside, that shaves the peak of the impact of that terrain to the electric utility in a way that makes it much more efficient to them to operate. And it has an impact from a utility standpoint, ultimately, that it provides the lowest cost rates to the rate payers, which are you and I and every user of electricity within a given grid. It provides the lowest cost option for them to operate, which is then passed on to the consumer based on regulation in every state.
Yeah, and so like as a shorthand, and I've actually been really interested in this, where if you have geothermal heating and cooling yourself, you'll save money over the life of the equipment compared to a typical HVAC system. But you also might very well save your neighbors money as well in terms of just overall power costs by
You're helping them in a small way. They may owe you a Diet Coke or a beer for the help you're giving them on their rates. Yep,
it can add up if it's enough. But
absolutely.
yeah, and these days Diet Coke or a beer is sounds good to me.
Yep.
Well, last thing before we pivot to Ryan is, looking ahead, what do you see in terms of opportunities for growth, and what are you excited about, and how are you incorporating that into your planning as a manufacturer, as an employer in the state of Indiana and the Fort Wayne area, and all that?
Yep. So great question. And I'll try to be concise because we could get excited and talk about it for quite some time. I guess to make a couple of points, I've just always viewed managing energy cost as a fundamental and foundational input to an effective and growing economy. And right now, the world and good old US and North America are in a mode where expanding our energy options and providing diversity and independence on global activities and the cost of energy, it'll be good for our economy and good for our society over time. And if you talk to a building owner and or a homeowner and you explain to them that they already own 75 to 80% of the thermal energy they'll ever need to heat their home and or their building and make hot water, you're going to need to explain that because it's not intuitive. But with the equipment that Larry and Peter install and design every day, that's actually the fact that the thermal energy is already on the property where your home or building exists to provide 75 to 80% of all the thermal energy needs that you'll have going forward. So it's a pretty vivid example of what energy to independence can look like for an individual homeowner or an individual building owner. I think the other thing to think about in terms of what to get excited about is providing the lowest cost options over the life cycle of the equipment for building owners and homeowners. That's fundamentally beneficial. And then just to sew the button back on what Larry was talking about earlier in terms of the opportunity for jobs and what kind of opportunities exist for well-paid, high-skilled jobs for individual small business contractors across the country. It's like we've taken the entire country and said everybody has access to a energy source that can be utilized everywhere. And that's a very unique paradigm versus the way we've operated over the last, say, 100 years with the evolution of the current energy system. So there's some exciting times out there. And the good news is we're starting to see more and more traction and awareness and interest in terms of we want to consider geothermal heating and cooling as an option for our next construction project or for my home when my furnace or heat pump or air conditioner goes out.
Great. Yeah. And that was as good a preview as any for we're going to do a few more of these webinars. Want to drill deep into workforce development opportunities, into grid resilience, grid management, and just overall investment at the utility level, and then unpack some marquee projects and really get into what their anatomy is like, and what this looks like when you're starting to pencil out numbers and deploy at scale. Which is a nice segue. Last but not least, Ryan Dougherty, the doc. Care to introduce yourself?
Yeah, thanks so much, Scott. It's a pleasure to be here today. And Peter, John, and Larry are certainly tough acts to follow. But want to introduce myself, Ryan Dougherty with GeoExchange. We're a nonprofit trade association representing companies and stakeholders in the geothermal heating and cooling industry. And our mission is pretty simple. We aim to accelerate the deployment of the most efficient and effective heating and cooling technology in existence, which are ground source geothermal heat pump systems. And you could be forgiven for thinking that this is a niche technology, but it's already installed in over 1.3 million homes and businesses across the country. Most people don't know that though. And the reason for today's webinar and for the future webinars is to really give voice to the technology, to the value chain, to the success stories that more and more people are learning about. But we really need to do a better job as an industry of amplifying. So grateful to you, Scott, for helping put this together, and look forward to digging in a little bit.
Yeah, no, terrific. I think you hit the nail on the head, which is geothermal is trending. I feel like there have been more hits in the news and on Google on geothermal energy and geothermal heating and cooling in the past 6, 7 weeks than maybe in the prior decade. I mean, it really seems like it's ascending. There's a lot of interest, and rightly so. And um, from a policy perspective, you know, given all of its attributes in terms of cost savings and grid resilience, in terms of the workforce opportunities that it creates, that makes it the kind of thing that is deserving of policy support, especially because it's a inherently domestic industry. You can't outsource geothermal heat. This is all made in the USA. So without getting into the minutia of the tax code, wondering how you'd characterize kind of where the industry is in the policy space and what the outlook is in the near term, and then maybe a little bit beyond the near term.
Yeah, happy to do that. And in order to look forward, I think it's often useful to look back. I think you mentioned in your conversation with Larry some commonalities with the oil and gas industry, and the geothermal industry and this technology really sprang out of oil and gas in Oklahoma in the 1970s, where drillers and subsurface geologists were not just looking for oil and gas, but they were also finding a limitless supply of heat down there. And John talked about the common sense value of that and just using what is at your disposal. As the industry matured throughout the 80s, it was states like Oklahoma, Indiana, where elected officials, regulators, utility executives realized that we should support this because it's good for America, it's good for the economy, it's good for our energy security. And that's really when a sort of a mission and a purpose materialized to give this technology a fair shake. And so, thanks to folks who really saw fit to get the technology included in the tax code, we first entered the revenue code in 2008. And it's because of strong bipartisan support from folks in the Oklahoma delegation, in the Indiana delegation, who have really gone to bat for us on Capitol Hill, in regulatory bodies, to say, hey, this is great stuff. We've got to support it and see it through and help grow and amplify this technology and its adoption. So it's been a bit of a roller coaster. I mean, Congress has been in the habit of picking winners and losers. And although we've got 1.3 million systems in operation, that's a very small fraction of the overall built environment. So we've been a bit of an afterthought in some ways. And so our mission now is to really get the message out, to build and capitalize on that pre-existing bipartisan support. And what we're looking for is certainty. In order for Larry and John and Peter to continue to draw investment and to continue to make investments in their own businesses, you can't be whiplashed back and forth by one being in one day and out the next. So tax certainty is certainly something we're looking for and advocating for in the future.
That's great. That's great. And that's a great way to wrap things up for today. Want to be mindful and respectful of everyone's time and make this, digestible enough. We will be coming back in the coming weeks with other topics as part of geothermal heating and cooling, and really want to try to be a resource, both reflect and substantiate the incredible expertise that's out there, and also bring new folks into the fold. It's not rocket science, it's rock science. Even so, we still want to try to break things down and spread the good word, and see what might flow from there. So on behalf of the group and Mission Geo and GeoExchange, I want to thank everyone who has tuned in. It's always a little strange when you're doing these things virtually. You have no idea who's all out there, but nevertheless, we're very grateful. And also a big thanks to our panelists for bringing your expertise and your energy for today. There'll be summaries circulated, both on paper and the audio itself, and then ultimately kind of a supercut of the Sports Center highlights of what we've talked about. And we'll be back with more in the coming weeks. So again, big thanks to everybody, and have a good weekend.